Hello everyone and welcome to re-entry. In this video we will take a look at how to bring the Gemini spacecraft through the atmosphere down to a safe landing in the ocean. Currently the spacecraft is crossing the lower part of Africa, and if I take a look at the orbit view you can see that this is my current location. Our trajectory will intersect the atmosphere and the Earth, as you can see with this white prediction line here. So what will happen is that we're currently flying at a velocity of 25,500 feet per second, somewhere around there, and we will fly through the atmosphere to bleed that velocity off and come to a safe splashdown. This means that as we go through the atmosphere, the dense layers of air will start to reduce the velocity of a spacecraft, thus increasing the G loads. So as we maneuver through the atmosphere, we will need to make sure that our G loads don't get too high. So the Gemini spacecraft is designed so it can produce lift. And if I now take a look at the spacecraft from the side and I hit pause on the simulation here, you can see that the heat shield is now kind of facing in the direction of our velocity. So we're basically in a blunt and forward attitude. The astronauts are then looking out through the windows, and if I now enter the cockpit again and I'll continue to play, you can see that Africa is moving away from us through the window. This means that we are in the correct attitude for entry. Now, if we are to understand how the lift vector in Gemini works, I'm going to open up a blank piece of paper to just quickly draw out what we're about to do. So I'm still going to be in external view, and I'm going to hit pause, and I'm going to be drawing Earth here. And then I will draw our spacecraft here. This is the Gemini spacecraft. There we go. And this is the heat shield. So as we travel, the density of the air will hit the spacecraft like this. And in this case, we have an angle of our capsule so that the air will try to kind of get under the capsule like this. Some will probably bleed over, but most of it will go down here, producing a lift vector upwards. And if this is the windows and the astronauts are basically sitting in here, flying the spacecraft, this means that the lift vector will be pointing up. So if you're looking out the window and you could, for example, see Earth in the lower part of the window, then you would be having a lift vector that points up. However, if we would be traveling to the atmosphere at this attitude, like this, and this is the direction of our drag, then air would be going off like this, producing a lift vector down towards Earth. And in this case, the windows are here and the astronauts are basically flying the spacecraft here. So in this case, you would see Earth in kind of the upper part of your window. So you would basically be upside down. And this is important to know because once you're flying through the atmosphere, you will need to control this lift vector. Now, one last drawing. To be able to control this lift vector, the Gemini spacecraft has been designed to have an offset on its center of gravity. So let's just pretend that the center of gravity is here. This means that as air travels around the capsule, if the center of gravity would be in the middle, equal portion would go like this. But since it's not in the middle, it will have a natural kind of tilt towards the center of gravity. So in this case, the spacecraft would automatically then tilt itself to base of the offset of the center of gravity. This means that using roll, you will be able to maneuver the spacecraft and control the lift vector. And it's a very simple rule. Right now, you can see that Earth is going away from us and our heads are up. This means that the lift vector would also be pointing up. If we would see Earth in the top here, our heads would be pointing down towards Earth, which also would point our lift vector down towards Earth. So in this case, we are now going to maneuver the spacecraft through the atmosphere, and I'm going to open up the correct checklist for this. So we just done our first section of entry, which is pre-retro, the retro firing itself. We jettisoned the retro engine and powered down some things. And now we're about to perform the entry maneuver checklist. And the first cue here is that at about 400,000 feet of altitude, we are going to start our entry interface. At this time, since our computer is running the re-entry software and is fully loaded, we can see that it's now running. This will soon change to show us the distance to the predicted splashdown point, which is out in the ocean here. And we're about to now leave Africa and hit that 400,000 feet pretty soon. So I'm going to use timescale until we hit that milestone. And that is basically the first step of entry. There we go. We're now at 400,000 feet of altitude. There's still a little bit of time until we are going to detect the first G's. That's the 0.05 G marker. And once we are starting to hit the upper parts of the atmosphere, you will see that the G meter here will indicate an increase in G. And based on our lift vector, if we're heads up or heads down, this G's will rapidly increase or slowly increase. And we can use the lift vector to both increase and decrease the G load as we venture through the atmosphere. So right now I'm going to use timescale again until we hit that upper part of the atmosphere. And that's it. It will automatically stop timescale ahead of time, so you should be safe to just use timescale until the simulator automatically stops everything for you. So currently we are all set up for entry, since we've done all of the entry checklists. The next thing that will happen now is that we will hit the atmosphere with a lift vector in the upward direction. Since the center of gravity offset is slightly tilted, you can see that because we have some slight air drag right now, the capsule will automatically maneuver itself towards this stable trim attitude. That's the atmospheric trim attitude. And as you can see right now, we're traveling with the air kind of coming through the capsule and pushing us, acting like, so we act like a wing, and in this case our lift vector is then pointing upwards. So right now, once I hit the more denser part of the atmosphere, we are slowly going to build up our G's, but we are going to kind of just skip the atmosphere slightly, meaning it won't dive that fast in. However, if we were to now rotate the spacecraft, we would dive into the atmosphere and the G's would start to build up quite fast. So now you can see that the IVIs is showing a positive range towards the predicted splashdown point, and this is in nautical miles, and this is the distance that we want to travel. Now, using the lift vector, we can also control how quickly we get through the atmosphere. The quicker you get through it, the shorter you will travel. And if you're have a far distance to travel, it's wise to kind of keep as much time as possible in the upper layers of the atmosphere before most of your velocity has been turned into heat. Since now we have the most energy, we have also the capability to travel the furthest. So right now I'm going to keep this a little bit in the heads up direction. And you can notice that the G meter is slightly now trying to build up towards the 1 marker. Another very important instrument during this maneuvering is the descent meter. This will tell you what direction you're traveling in. So at one point, if you're having the lift vector up through the denser part, you will start to shift the direction, how fast you fall, and maybe even start to climb again. And this can be seen here. And then lastly, it's important to pay attention to the altimeter here. Once we are below 100k feet, this will start to count down towards when we are going to splash down in the ocean. And at that time, it is important to have the chutes ready so we don't splash down too hard. Okay, the G's are now building up. And I'm going to keep the heads up direction right now a little bit further because of the distance that I want to travel. You don't really need to care too much about this, especially if this is the first time you're about to enter. So we're closing in on 2 Gs. Okay. And now I'm going to dive into the atmosphere. And now take a look at the G meters now. Since we're now kind of pointing our wing down towards Earth, we are basically diving down towards the surface, which will mean that we are increasing the G loads quite rapidly, especially once we hit the most dense part of the atmosphere. And at that point, it is always important to quickly rotate the craft again, reverse the roll to get out safely, or else you are going to get hit by those Gs that will eventually crush the spacecraft. Right, I'm at 4 Gs, and I'm going to play it safe, and I'm going to roll this slowly so the lift vector goes up. And don't worry, you might hit those 9 Gs, and that's fine. Try to not go above 10 Gs, but between 6 and 9 Gs is quite normal for an entry with Gemini. And now the spacecraft is reducing its drop speed, that's the vertical speed, as my lift vector is pointing upwards. And you can see that that also limited my Gs to about 7.5 Gs, and now it's climbing back down. And I could make this constant because I want to drop down as soon as possible because my landing spot is right now kind of below me, and I passed it. And now I'm going to skip down for the final dive into the atmosphere. Now this might increase my Gs a little bit further. My velocity now is it's reduced quite a lot as I've been traveling through the denser part of the atmosphere. So you can see that the distance to the landing site is not increasing or decreasing that much anymore. And once this one is counting down, it's you can start to look away from the Gs. Those will rapidly lead off, and you should always prepare for landing. So basically, there's a couple of things that we need to make sure. And the first thing is that our landing system is armed. So make sure that this one is up, or else you will not be able to deploy any chutes. I'm going to hit run on this checklist. And this will basically ask me to turn on the controllers and also open up the high altitude drogue when this light is on. There we go. And that's our first chute. You can turn off the RCS. It's important to do that during entry. Now that the chute is on, you don't want to fight that. And the next milestone is 10,000 feet. That's or 10.6. That's when our main chutes are about to be deployed. The D-ring is basically just the ejection seat, just in case you need to use that. I will also turn off the attitude indicator. And same goes for the attitude indicator light. Just turn on the red ones here just for fun. You can always mess around with the lighting to get it into your liking. Okay, we're now at the 10K marker, and that's when it wants us to deploy our main chutes, 10.6K. And that's done by pressing the para button here. Okay, main chutes are out. The Mercury spacecraft and the Apollo command module, they are all splashed down in the ocean with the heat shield kind of down into the ocean. The Gemini spacecraft has been designed to land sideways like some kind of a boat. So the way to enter this landing attitude is to use this last switch here, or the third switch here. And if I hit this button here, a line will be cut on the chute system that allows the spacecraft to just fall down on this sideward position. So now it will land in the ocean in this attitude here. I'll continue off with the after main deploys checklist. That's continue to power down a couple of the systems. Once we have landed, there's a post-landing checklist as well that will power down most of the systems that we don't need anymore. There goes the computer. Thank you for everything. And then the platform, gyros, guidance, reaction control systems, the joysticks, controllers, and lastly the D-ring. D-ring, it's already deployed, but do not pull this. So, as mentioned, during entry, it is very important to maneuver so that you control your lift vector. The lift vector is following the direction of your head. So if your head's up, then you're relative to Earth, then the lift vector is up. If your head's down relative to Earth, then your lift vector is down towards Earth. Use this lift vector to control the rate of vertical velocity, how fast you fall. The faster you fall through the denser part of the atmosphere at the higher velocity, the more G's you will build. So you will need to make sure that you reduce that downwards velocity by using the lift vector. In addition, you can also control how long you want the lift vector to point up, both on the initial part of the descent, especially if the trajectory is bound to hit Earth, which means that it intersects Earth, as well as during that first roll reversal after hitting high G's. Both those two time frames can be used to increase the range to your landing point. So currently I crossed the landing point slightly, but not by too much. And we're about to hit the water, about 30 meters. There we go. And splashdown. And that's how you get through the atmosphere. The one last thing that we need to do is to perform the post-landing checklist. And I will be just running through this very fast, just to kind of show the main antennas. First of all, it wants me to extend the antenna for about 30 seconds. That's when the HF antenna grows out of the exterior. And after those 30 seconds, that will need to be set to off. We can de-arm our landing systems. We'll set our radios accordingly. And then we can start to depower quite a lot of things. And all of these are just systems that you have been using either during ascent or orbit or during entry. Since we don't have infinite resources on board, it is important to save all of the resources so everything of essential got power until pickup. And there we go. The spacecraft is now floating and we are waiting for our pickup. If we would open our hatch, the real Gemini spacecraft would have a little piece of cloth here that would prevent water from the waves to come in. But just a little fun thing to do on the boat. So anyways, I hope that you liked this video, and I hope that it helps. If you want me to continue to add some more videos, please let me know and give me feedback in the comments section, and hit that subscribe button. So thank you again for watching, and I'll hope to see you in the next video.